Attention. Right, this question now is on the first derivative. Right, now before I go any further, I just wanted to give you this information with regard to the cubic function. Remember, the general equation is ax cubed plus bx squared plus cx plus d. Then, if you find the first derivative of that, you get 3ax squared plus 2bx plus c. The first derivative of any cubic function is quadratic. Then, the second derivative is going to be 6ax plus 2b. The second derivative is a linear function. Okay, now sometimes you can get a question with a first derivative, okay, no cubic function given. So in that case now you need to remember that the first derivative of a cubic function is quadratic. Okay, so that's what is expected in terms of this question now. This question was from 2016. There was no cubic function given. We only get the first derivative. So you work backwards now, from your first derivative towards your cubic. So you need to be aware of that. All right. So the first question, it says calculate the x coordinates of the stationary points. Now that's easy because all we have to do is, if you are given the first derivative, you equate it to 0 because the first derivative is given. So this will be 3x squared plus 8x minus 3 equals 0. Alright? Then we need to factorize this. Okay? You can factorize or you can use the quadratic formula. Alright? Now if I multiply these two, I'll get minus 9. Which two factors of minus 9 can add up to 8? Minus 1. Which two factors of minus 9 can add up to 8? It will be minus 1 and 9, right? So I can write this as 3x squared plus 9x minus x minus 3 equals 0. Please, don't worry, you can just use the quadratic formula. I'm going to factorize. I'm not teaching factorization here. So this, if I factorize this, I'll get x plus 3 times 3x minus 1 equals 0. So my 2x values will be x equal to minus 3 and x equal to the third. Okay, so those are the x coordinates. And then I'm done. Okay, the question is very straightforward. It says calculate the x coordinates of the stationary point of f. So that's straightforward. We are given the first derivative. The first derivative of a cubic function is quadratic. So if we equate it to 0, we form a quadratic equation, and then we solve that quadratic equation. So which is what I have done. It's very straightforward. So in actual fact, this question 9.1, it's more like they are testing you how to solve a quadratic equation from grade 11. The calculus is only here where you substitute that first derivative to 0 because it's a stationary point, or rather we want to find the coordinates of the stationary point. Okay. Then the next question now says, for which values of x is f concave down? For which values of x is f concave down? Okay, I'm not sure whether you are aware that there are actually, I would say, 3 ways of doing this question. Okay, 3 ways. I'm just going to share with you all 3. The first method, which I normally prefer, if If a cubic graph is concave down, it means the second derivative must be negative. Okay, so let's go to that question 9.2. The new form. Okay, so we're going to do that. Let's start with method 1. Method 1. Method 1, if the cubic function is concave down, the second derivative must be negative. So in my case, the way that I memorize this is with concave down, okay, with concave down, because of the weight down, I consider that to be negative. Okay? If it's concave up, I consider up to be what? Positive. But since I'm dealing with concavity, it's concave down, all I need is to find the second derivative, and then I have to use the inequality sign, the less than sign. It has to be less than 0 if the function is concave down. So what's my second derivative? My second derivative is 6x, right, plus 8 is less than 0. When you solve this inequality, 6x is less than minus 8, then x is going to be less than minus 4 over 2. So this is method 1. Okay, this is my preferred method. But if you don't like it, you don't like this one here, then method 2, instead of equating, or rather instead of saying the second derivative is less than 0, you can replace the inequality sign by an equal sign. Okay? But now, that scenario is a little bit tricky because if the graph is not given, you are going to have problems because if you find the x value at the point of inflection, you are going to have challenges to interpret that x value. Are you following what I'm saying? So method 2, we can find the x value at the point of inflection. But the problem is, for this question here, the graph is not given. So how are you going to use that x value? It's going to be a nightmare. You understand? Which means method 1 will be the best method for this question. And the good thing about this method here, it works for any question on concavity. If it's concave up, you replace the inequality sign by a greater than sign. So this method here, it works for any question on concavity. But if I use method 2 now, it means I might need to sketch the graph itself, which to draw like a sketch, okay, which is more complex. So f double prime of x is equal to 0. So I just take that 6x plus 8 equal to 0. If I solve this, I'll get x equal to minus 4 over 3. But now I'm going to have a problem now to use this value here to determine the values of x for which the graph is concave down. Alright, now it's not like that complicated, but it requires you to know more. How many of you agree with me that if I move from the first derivative to the original cubic function, okay, that cubic function is going to be, it's going to be f of x equal to what? Remember, to get this 3x squared, well, what happened to the original cubic function? What was the coefficient of the x cubed term? It was a 1. Okay? If the coefficient of the x cubed term was a 1, what does that tell you in terms of the shape of the graph? Is it like this, or is it like that? Okay, remember, if a is positive for a quadratic function, you have a minimum turning point, right? So for the cubic, it's the opposite. You start with a what? The maximum. So it will be like that. Alright? Now, the challenge now is to know where is x equal to minus 4 over 3 for that stage. Okay? So you find that method 2 is not advisable for this question because you are not given the sketch. You end up wasting time to determine the shape of the graph and to determine where x equals minus 4 over 3 is on that graph. So this will be the best what? Method for that question. But let's just go back to the basics. So this is x cubed. What about this? How did you get this 8x? It will be what? 4x squared. Am I right? Yes, sir. Okay. So this will be 4x squared. What about that minus 3? It will be minus 3x. Remember, the derivative of a linear is what? Is equal to the gradient of that linear. Then, do we know the y-intercept? Okay, they gave us in part 4, but I don't want to, I'll just put d there. So the original cubic function had that equation. So when you find the derivative of this, you will get that. But how are you going to be able to sketch it in order to answer this question? It's going to be difficult. So if you try to use this method for this question where the graph is not given, it will be a nightmare. So it would be better to, where's my tool? Okay, it's here. It's hiding. Right, it's better to memorize this than to try to use method 2. For this question, it won't work. And I can tell you that most learners for this question here, they will have problems answering this question. Because if you don't know this, you are going to try to do it this way, and you get stuck after finding the x value at the point of inflection because you don't have the graph sketched. So how are you going to use it to get the answer? It's going to be a problem. But if you want, you can sketch that quadratic function and then try to work backwards. Take you long. So I'm not going to encourage this method for this question. Okay? Method 3. Okay, method 3 is to use, you saw the x values which I got here. Those x values at the point of inflection. If I find their average, okay, it will be equal to the x value at the point of inflection. So the x value at the point of inflection will be equal to x1 plus x2 all over 2. I hope you know this. Huh? Do you remember this? So we have got minus 3 in the third. So that will be minus 3 plus the third over 2. Again, this will give you minus 4 over 3. But the problem now, again, is the same as method 2. You have problems in terms of using this value to answer the question. So I don't encourage this method if the cubic graph is not given. Are you following? Yeah. These three methods, in fact, method 2 and method 3, they can be used if the graph is already sketched or if you sketched it yourself. But if it's not given, method 2 and method 3 are not good methods. They will cause you to have major problems. You end up wasting time trying to figure out how to get the answer. It's just 3 marks. Maybe you will get 1 mark for finding x value at the point of inflection. In the end, you end up getting 1 out of 3. But if you memorize this inequality here, okay, use this for any question on concavity, you won't have any issues. Are you following? Okay, so this is our answer. I just spoke about method 2 and 3 just to let you know that it's not always that you can use them, especially when you have a case where the graph is not sketched. You can't use method 2 and method 3. Okay, let's move on to 9.3. Okay, now 9.3 says determine the values of x for which f is strictly increasing. When is a graph increasing? Now, please remember, this is not the first derivative, it's the original function. When is it increasing? Yes? Yes, and the grade is positive. Thank you. So, all we have to do there, we have got our first derivative. Okay? Now, here you need your knowledge of quadratic inequalities. Remember quadratic inequalities? Yeah. You will need that here. So, if the original cubic function is strictly increasing, it means its first derivative must be greater than 0. Okay? It must be greater than what? 0. The good thing is, we already solved this and we've got two x values. Remember, we've got those two x values, these two values here, they will be our critical values. Okay? They will be our critical values. So, I'll just write it CV. Okay? We have got x equal to minus 3 or x equal to a third. Let me just check if I'm writing it correctly. Okay? Yeah. So we've got our critical values already. Okay? From the first question. So we can use the number line method, or we can use the table method, or we can use the graphical what? Method. So I'm going to use the graphical method. Again, I can tell that this question will cause issues. So we have got minus 3 and we have got a third. So we have got that. You know what? I still don't understand why you learners have got problems with quadratic inequalities. I still don't understand. Alright, you see this coefficient here of x squared. If it's positive, it means the quadratic function will look like what? Like that, where the minimum turning point. Right? Then, I hope you remember your quadratic function. Okay, do you know that f prime of x, we can call it y? You agree with me there? So what that means is, this trinomial here, it's equal to y. Okay? So this whole expression, we can write in terms of y and say y is greater than what? 0. Where is y greater than 0? Because this horizontal line here is going to be like your x-axis. Below the x-axis, y is what? Negative. Above x-axis, y is what? Positive. So if there's a greater than sign here, it means you just have to look at the left-hand side of minus 3 and the right-hand side of a third. So your two answers for that question are going to be x is less than minus 3 or x is greater than a third. Those are the two answers. The question is 2 marks. So everything I've written down here is actually not necessary. I'm writing it because I'm a teacher, because I wanted to show you how I get my answer. But these are the two answers. 1 mark for x is less than minus 3. The second mark for x is greater than a third. If you don't like this method, then you can use the number line method. There's also a table method. I don't know how you were taught, but in my case, I think in recent years, I decided to use the graphical method, but I also teach the number line method. There was a time when I used to teach the table method with the number line method, then I changed. So now I prefer the graphical method. It's the easiest. Be aware that this trinomial is equal to y. So this is the same as y is greater than 0. This horizontal line which I drew here, that's like your x-axis. I'm sure you all know that above x-axis, y is positive. Below the x-axis, y is what? Negative. So if you have got a greater than sign like this, you just have to look to the left-hand side of the x-intercept. So to the left-hand side and the right-hand side of the x-intercept. And then you get your answers. I don't understand why this is so complicated. Because it's very easy. So your knowledge of quadratic inequalities as well. If you've got a calculator, see, most of you don't have good calculators. You see, this calculator really, it's not for someone who is in your machine. I hope you know. I'm telling you, if you're in a machine, you're not supposed to do this. Is for grade 8 and 9 calculator. Right? Then this calculator, there's a calculator which can solve quadratic inequalities. Okay, this one is a little bit better than that, but it's also less advanced. This calculator is very calculator which can solve quadratic inequalities. Do you know that there's a calculator like this which can solve quadratic inequalities? Huh? No. Yeah, maybe. I think this one also is a sort of one. It also is the same. Right. But there's an advanced version which can solve quadratic inequalities. Okay? It can help you if you don't want to do it on your own. Okay? Any question? Any question? Ria, are you following? Please be aware that quadratic inequalities, they are tested as part of question 1, paper 1. You always get a question on quadratic inequalities. They are also tested under the quadratic function. They may also be tested under the cubic function. But you cannot write a paper 1 where you don't need to know quadratic inequality. It's not possible. And this is very easy. This question can be done by inspection. That's why it's 2 marks. All right, then let's move on to 9.4. 9.4, if you understood what I said at the beginning with regard to this, okay, then you won't have any problems to answer 9.4. We are working backwards from the first derivative towards the original cubic function. Okay, so we are doing 9.4. So 9.4, we are told that the equation of the function is ax cubed plus bx squared plus cx plus d. And the x-intercept, the y-intercept, it's minus 18. I hope you know that this means the y-intercept. X is 0, y is minus what? 18. So that's the y-intercept. So minus 18 is the value of d. Okay? So we just want to determine the equation. Okay? Now to find the equation, it's not complicated. We are given f prime of x is equal to 3x squared plus 8x minus 3. How many of you have ever heard the method called comparing coefficients? Okay. This year, the way in which I taught how to solve cubic equations was slightly different from the past years, but there's also another method where you compare coefficients. Okay, I'll show you how it's done. So the first derivative is that, but our given equation for f of x is equal to ax cubed plus bx squared plus cx plus d. Okay, so if I find the derivative of f of x, okay, in terms of a, b, and c, I'll get 3ax squared plus 2bx plus c. Right? Then I can now compare this equation, okay, in terms of its coefficients and that equation in terms of its coefficients. I'll just compare them so that I can determine the values of a, b, and c. Okay? So if I do that, okay, this term, make sure you pay attention. This 3x squared is going to be equivalent to that. So 3ax squared is going to be 3x squared. So if I ask you what would be the value of a, what would be your answer? What? 1. You see this 3 and that 3, they cancel out, right? This x squared and that x squared they cancel out. So you're left with a equal to what? 1. I just compared the two. Okay? In actual fact, the way that I did there, I'm not comparing the coefficients, but I'm just solving that. Then you do the same for that one. Okay, so it will be, let me use a different color. I think maybe that color will be better. So this 8x will be equivalent to that. Okay? So it will be 2bx is equal to 8x. Okay? Obviously, I will end up having 2b equal to x. So b is going to be what? 4. Do you remember we got this before? When we did it by inspection? Yeah. When we did that by inspection, yeah. You see this 4 here? You see that? We got that 4 by inspection. And then we need C, obviously. So C means minus 3 is going to be equal to, you see? Minus 3 is CX. Okay. Minus 3 is going to be equal to CX. Okay, this one is minus 3 is going to be equal to C. We are comparing this and that. You see that? So C is going to be what? Minus 3. Therefore, our equation, okay, is going to be f of x. I think let me write it down. So therefore, our equation is going to be f of x equal to x cubed, right, minus 4x, minus of positive 4, positive 4, no, it's supposed to be positive 4x squared, right? Then my c is negative, so that will be minus 3x, and my d is minus 18. So that will be the equation. This is the equation of f of x. Okay? So I've used the first derivative together with my knowledge of the first derivative and its original cubic function. All right? Okay, any question? Yes?
Do you have to write something that contains stuff in this recipe?
Which one?
Like,
are you talking about showing this way?
You have to show.
Yes, 5 marks.
Okay, one thing that
it's 5 marks. Okay? I've given it 5 marks. So some of the marks they go to the working out of A, B, and C. And then no. It's 5 marks. Those 5 marks they should tell you that you need to do a bit of some working out. Okay? So that will be.
Then why did they write up in the question and say show all working?
Yeah, it's written on the first page. You see when you write your paper. Under instructions. I hope you know this. If you're not aware, please be aware of this.